ಇನ್ನಿಂತ್ರ ಕವರ್ ಆಗತ್ತಾ? ಎಷ್ಟಾಗತ್ತಲ್ಲ? ಗೊತ್ತಾಯ್ತು. ಹಾಂ, ಗುಡ್ ಮಾರ್ನಿಂಗ್. Yesterday we have started the discussion about a new topic, very important topic, space technology. There we have discussed about Kepler's laws of planetary motion, then different orbits to which we can place different kind of satellites, right? Kepler's first law says, first law of orbits, simply it says all the planets revolve around the sun in elliptical orbit. Due to this elliptical revolution, seasons are formed. First law, right? Kepler's first law, law of orbits. Then we have Kepler's second law. It states law of equal areas. Law of equal areas. That means planets revolve around the sun in elliptical orbit. If the planet is very close to the sun in a given duration of time, it will travel more distance. If it is far from the sun in a given duration, it will travel less distance. For example, let's say in 1 month time. But the area swept during this time, the area swept during this unit time is same. Law of equal areas. Simply in general terms, we can say if the planet is near to the sun, orbital velocity is more. If the planet is far from the sun, orbital velocity and gravitational force both are less, right? Both gravitational force and orbital velocity is less. If the planet is very close to the sun, then this shortest distance is called as perihelion, right? In the center, if Earth is there, then perigee. Sun is there, that's why perihelion. The farthest distance, aphelion. In case of Earth, apogee, right? Then we have Kepler's third law. Third law states law of periods. Third law. If the orbit of the planet is smaller, it will take less time for one revolution. If the orbit is bigger, it will take more time for one revolution. Simple. If the orbit is smaller, it will take less time for one revolution. If the orbit is bigger, it will take more time for one revolution. That can be simply stated as square of the time taken for one revolution is directly proportional to cube of the mean distance. Square of the time taken directly proportional to the cube of mean distance, right? Kepler's third law. Then we have discussed about the different type of orbits. The shape of our Earth is, shape of our Earth, how it is? Oblate sphere, bulged in the middle, flattened at the top and bottom. Simply we can say geoid shape. That is nothing but Earth-like shape, right? From 200 kilometer to 2000 kilometer, from 200 kilometer to 2000 kilometer, we have from the surface of Earth 200 to 2000 kilometer. We have which orbit? 200 to 2000? Low Earth orbit. In the low Earth orbit, the satellites which are placed will be moving at slow or higher speed. Higher speed, because the gravitational force is more, it will be moving at a higher speed. Which kind of satellites can be placed in the low Earth orbit? Yes, space stations are there, space telescopes are there, then observation satellite, remote sensing satellites are there in the low Earth orbit. By using a special method technology, Starlink and Project Kuiper, these projects by SpaceX and Amazon respectively, what they are doing? They are planting thousands of satellites into the low Earth orbit. Each satellite will be interconnected to the other satellite, by which high-speed internet connection can be attained. Low Earth orbit only, right? Generally, in the low Earth orbit, communications satellites cannot be placed. From pole to pole, polar region to polar region. Which satellite? Polar region to polar region. Polar orbit, we say, right? Polar orbit. 360-degree observation of Earth is possible. Google Earth-like feature uses polar orbit satellite. Okay, polar orbit. Then we have sun synchronous orbit. Sun synchronous orbit means this is also 600 to 800 kilometer only. Sun synchronous orbit. Sun synchronous orbit. That means as the sunlight moves, the satellite will also travel in synchrony with the sun. Wherever the sunlight is falling right now, the satellite is there. That kind of observation satellite, sun synchronous orbit. Then we have 35,786 kilometer, at a distance of 35,786 kilometer. If it is horizontally above the equator, then geosynchronous equatorial orbit. If it is anywhere inclined, then it is geosynchronous orbit. Same 35,786 kilometer distance. In the geosynchronous orbit, which type of satellites can be placed? Communication satellite, DTH satellite, in the geosynchronous equatorial orbit. Okay, in the equatorial orbit, they are there. Weather observation and forecasting satellites can be placed in the geosynchronous orbit. Then we have medium Earth orbit, right? Medium Earth orbit means from 2000 kilometer to 35,786 kilometer. We have medium Earth orbit. There we can place navigational satellites. America's navigation satellite system's name is GPS, Global Positioning System. Russia's navigation system name is GLONASS, Global Navigation Satellite System. European Union's Galileo, European Union. Then Japan, QZSS, Quasi Zenith Satellite System. Then we have our very own India's. Earlier it was called as Indian Regional Navigation Satellite System, IRNSS. Right now the name changed to NAVIC, Navigation with Indian Constellation, NAVIC system we have. China, BIDO, BADOU. BIDO, China have its own navigation system, right? Then today we'll start. What do you mean? Have you heard the name escape velocity? Escape velocity. Have you heard? This is the minimum velocity required by an object to escape Earth's gravitational pull. Why apple fell on or beside Newton? Due to gravitational force, right? But even moon is attracted towards Earth due to Earth's gravitational pull. But there is a difference. Due to the lesser gravitational pull, it is revolving around the Earth. Due to the more gravitational force, it falls. The object falls on the surface of the Earth, right? There is a minimum force required to escape this Earth's gravity. so that the satellites can be placed into the revolving orbit. The minimum velocity is called as escape velocity. Escape velocity, that is 11.2 kilometer per second. Escape velocity. Kilometer per second, just imagine. 11.2 kilometer per second. Minimum velocity required by a satellite, space shuttle, object, etc. to escape Earth's gravity. To escape Earth's gravity, escape velocity. Then let us see different launch vehicles, satellite launch vehicles, which we have right now.
In this field, it cannot attract that.
No, actually, see, we have atmosphere right around the Earth. Troposphere, stratosphere, mesosphere, thermosphere, exosphere, right? The rocket, let's say PSLV, it should escape the Earth's gravitational pull and reach the rotational orbit, 200 kilometer, 250 kilometer, 300 kilometers, so and so. To escape from this gravitational pull, the minimum speed required is this much. If it goes at a lower speed, it cannot escape. It cannot reach the space. Beyond, it can, obviously. If it is below, it cannot. That is the case. 11.2 kilometer per second, just imagine, that is around 40,000 kilometer per hour. The normal super bikes, super cars, supercharged bikes, which might go at a speed of, normal bikes will go 500, 600 cc, 180, 200 kilometers. That will Ninja H2, etc. kind of bikes will go 300, 400 kilometers, right? That is a very much higher speed for us. But here, just imagine 40,000 kilometer per hour, the escape velocity required. Do you know, have you heard about Kalpana Chawla? Kalpana Chawla, she is an Indian origin American citizen. Indian origin American citizen. She went into space many a times. Many times she went and she came back successfully. One fine day, when she was on a mission to research something, she went to International Space Station. While coming back in Columbia Space Shuttle, when the space shuttle entered Earth's atmosphere, Earth's gravity. See, if you don't wear the helmet and go speed of 180, 200 kilometers, if a small insect touches your face, you'll feel that impact, right? Impact will be higher, more, right? Even the wind blast will be very much higher, which we cannot withstand. Just imagine how much amount of friction that will be caused, fluid friction caused by the air when that object enters Earth's gravitation. Each and every space shuttle will go through that, but Columbia Space Shuttle failed to withstand that temperature, that much higher temperature. It busted into pieces. She died while entering the Earth's atmosphere. Okay. That's why India is planning to send human to space by its own space shuttle. Rakesh Sharma and recently Shubhanshu Shukla went into space with the help of other space agencies. Right? With NASA, he went. With Russia, the earlier one, Rakesh Sharma went. But now we are planning to send human to space. The name of the project is Gaganayana. Gaganayan program we are doing. Before sending human to space, you are planning to send a robot named Vyoma Mitra. Vyoma means space. Mitra means friend. Half humanoid robot. Half means it is only having the shape of the human till the waist. From waist to head only it is there. Half humanoid robot, Vyoma Mitra. It will go, it will check each and every functionalities and cabin temperature, pressure, etc. If it is suitable for a human to go, then it will confirm. Okay, you can go in the next mission. Likewise, They are planning. If Corona was not there, it would have been done by this time. Due to COVID and other reasons, it is being continuously postponed. In a year or two, it will be done. Vyoma Mitra. First, it will go. Later, Gaganayana program. We will be sending humans to space. Space in the sense International Space Station. They will go. They will make some research studies. Then they will come back. That's it. Escape velocity. Minimum velocity required. That is how much? 11.2 kilometer per second. Okay. See, right now we have polar satellite launch vehicles which we have. Polar satellite launch vehicle PSLV we have PSLV. Then we have geosynchronous satellite launch vehicle GSLV. Then we have geosynchronous satellite launch vehicle Mach 3 GSLV Mach 3 or LVM3. Then we have small satellite launch vehicle. The future technologies which we are developing are: one is new generation launch vehicle NGLV, then reusable launch vehicle, then a separate special engine which we are developing, scramjet engine. We'll discuss. Right now we have PSLV, then we have GSLV, then we have LVM3, GSLV Mach 3, then we have SSLV. We have right now four launch vehicles, four different type of launch vehicles we have. See, the first one, very important launch vehicle. Before that, 1975, India launched its first artificial satellite named Aryabhata. We didn't have any launch vehicle during that time. We got help from USSR, Russia. With their launch vehicle, Intercosmos 1, we have launched our first satellite. Later, we developed our very own launch vehicle named SLV-3, Satellite Launch Vehicle 3. SLV-3 upgraded to ASLV, Augmented Satellite Launch Vehicle. That ASLV upgraded to PSLV. Right now, we are not using SLV-3, we are not using ASLV, outdated launch vehicles, but we do have PSLV. This will go outdated in a year or two because its upgraded version NGLV will come, new generation launch vehicle. Okay. PSLV, very important, economical, efficient launch vehicle which we have. We have started late, right? When compared to other space agencies like Russia's Roscosmos, America's NASA, we have started late. By the time we have started our ISRO 1969, NASA landed their men on moon. Russia sent men and women to space. They have done these things by the time. We have started late, but we have made a tremendous growth achievement in this field. The main thing we are famous for is success rate. Success rate is high compared to other space agencies. Then cost effectiveness, very cheap, low cost. So you might have heard in recent days, our government is planning to lease cleaning vehicles, BVMP. They are planning to lease the road section cleaners. Are there, right? Have you seen a big truck under which that one they are planning to lease for 630 crores, 613 crores. That's why there is so much controversy going on these days. MP or opposition leader told, if you add 200 more crores, ISRO will do another Chandrayana program or another Mangalayana program by the amount which you are trying to spend just for cleaning the roads of Bangalore. Means that much efficient our launch program is, our ISRO's launch program. See, Polar Satellite Launch Vehicle, this PSLV rocket, small rocket only, this PSLV rocket is called as ISRO's workhorse. ISRO's workhorse because from 1999 till 2017, It had completed 36 successful launches. 36 successful launches continuously without any failure. In 2017, there was a failure while carrying a IRNSS satellite, Indian Regional Navigation Satellite System. It failed, but 36 successful launches, that too efficiently. That's why it is called as workhorse of ISRO. Even today, if we plan to launch any satellite with our PSLV, other countries will approach, telling that we do have a satellite, we will pay some money, please launch our satellite too. For example, with the help of PSLV only, we have made the world record, but it is broken now. World record by sending 104 satellites into different orbit, not a single orbit, different orbits in one attempt successfully. Later, the record was broken by SpaceX company. SpaceX company, in a single attempt, placed 143 satellites into the space. 143. We made 104 satellite launches. In those 104 satellite, the maximum number of satellites were from NASA, America, and many private companies also from America. Right? Likewise, our Polar satellite launch vehicle, indigenously developed in India only. It is called as an expendable launch system. Expendable means not expand, expendable, PEN. Expendable means it cannot be reused. Expendable launch system means it cannot be reused. It can only be used once. If you are doing a rocket launch today, means this rocket will be lost by the time it places the satellite into the orbit, because we have discussed yesterday. Each stage engine will be detached once its work is over. That is the case. Expendable launch system can be used only once.
36 times also they made no.
Yes, yes. Not 36, many a times, sir. 1999 to 2017, 36 successful launches. From 2017 to 2025, many launches have happened. During that time, it got the name Workhorse of ISRO. Okay. Each and every time, new rocket will be built.
Same
Specifications. Yes. There are so many types of PSLV are there. PSLV, XL category, etc., etc. I mean, the booster jet numbers, etc. That will be little specification, little different it will be. But the main stages of engine, the main payload capacity, that will be the same. PSLV. Polar satellite launch. That's why it takes huge amount of planning, huge amount of dedication, because from a year or two, they have planned for a single mission. If it fails, all those efforts will go in vain, right? That's why. That's why. Have you seen the video of Narendra Modi pacifying Dr. K. Sivan during the time of Chandrayaan 2 failure? Chandrayaan 2, we have planned to place a lander and a rover. Lander, landing device, rover, a remote car kind of thing, onto the surface of moon. That too, south pole of the moon, permanently darker side of the moon, permanently darker side. See, this is the light source. Okay, I'm standing like this. In the vacuum, diffusion of light will not happen. Diffusion means spreading of light everywhere. Here, air, dust, particles are there. That's why light diffuses. Even though light comes from this side, my rear back is visible, right? Because it diffuse, light will diffuse. Light travels in straight line, right? Straight line. Then this part of my face should only be visible. This should be darker side. That will not happen here because we have atmosphere. In the space, one face of the moon is towards the sun. That part will only be illuminated. The other darker side, south pole, is permanently dark. Permanently dark. That will not get light in its lifetime. We have landed a lander and rover to study if there is any rare mineral present there, etc. Chandrayaan 2 failed. It took another 1 to 3 years to make Chandrayana 3. Why? New rocket they need to build again. That is the reason. Till date, we don't have any reusable launch vehicle. We don't have any reusable launch vehicle. Who have?
Space.
SpaceX company have the reusable launch vehicle, but we don't have or reusable launch vehicle. Polar satellite launch vehicle in the 1990s. In the 1990s, ISRO developed its launch vehicle. The main intent of this launch vehicle is means its purpose is to launch a remote sensing satellite or observation satellites into the polar orbit. Polar orbit means pole to pole. Distance will be around 200 to 2000 kilometer to the polar orbit. That's why the name Polar Satellite Launch Vehicle, PSLV. That's why the name PSLV. Then to the low Earth orbit, that is also same distance, right? To the low Earth orbit. Then geo transfer orbit. Transfer orbit means what? Yes. The orbit will be highly elliptical, right? At one point it is very near to the Earth. At one point it is very far. So we'll place the satellite into the nearby orbit, geo transfer orbit. The satellite will move to the higher orbit by transferring it, by shooting it again, the engine, right? The main plan was this, but our PSLV rocket, see, Hero Splendor bike was made to use for daily commute, simple use. But that bike was used to do all India trip, inter-country trip, right? That can be done, right? People got to know it has more ability than what we have thought, than they have used to take it to. Some many people took it to Spiti, right? Likewise, they got to know Polar Satellite Launch Vehicle PSLV has a special ability that can be used not only to launch satellites for polar orbit, low Earth orbit, sun synchronous orbit, or geotransfer orbit, that can also be used to launch satellites to geosynchronous orbit or the orbit of Mars. The orbit of Mars by using the geotransfer orbit only they have placed. We'll see. Polar Satellite Launch Vehicle, PSLV. See the rocket, PSLV. PSLV C-47. You're seeing here, right? Each and every mission, each and every launch. See, for example, the name of the rocket is PSLV. Each and every time they will create a new rocket. First rocket number 1, 2, 3, 4. Likewise, they will give the name. Okay. PSLV C-46. The important missions PSLV have done till date. The very important mission Chandrayana 1. In the Chandrayana 1, we have placed only the orbiter. Orbiter means satellite which is orbiting in the orbit of Moon. Chandrayana 1. No lander rover. Only the satellite into the orbit of Moon. Chandrayana 1. It was successful. Launched in 2008. Chandrayana 1. We'll discuss milestone achievements of ISRO later. Okay. What are the important launches when it was done? We'll discuss. Then in 2014, we have made Mars Orbiter mission or Mangalayana. Mangalayana. Here also we used PSLV, Polar Satellite Launch Vehicle. By using geotransfer orbit. By using the geotransfer orbit, we have made this mission possible. In our PSLV rocket, we have 4 stages. 4 stages, nothing but 4 different type of engines at different levels. First one, the initial start, then just to travel. Later, the last part will be used to place the orbit, satellite into the particular orbit, the last one. We have 4 stages. First stage and third stage are solid fuel. No need to worry about the kind of fuel that is being used in these kind of satellites right now. If there is anything in news, new fuel introduced in PSLV, new sort of fuel which increases the efficiency. If anything in news like that, then only we need to worry. Otherwise, no need to worry. Solid fuel, the first and third stage. Then we have second and fourth stage, liquid fuel. Liquid fueled, second and fourth stage. We have Polar Satellite Launch Vehicle is known as workhorse of ISRO. Reason, without any failure from 1999 to 2017, it made 36 successful launches. Due to its consistency, due to its efficiency, it is called as workhorse of ISRO. Workhorse. ISRO's workhorse. Polar Satellite Launch Vehicle, PSLV. In India, where do we have our launch pad to launch the satellites? I mean, the rockets? In Andhra Pradesh. Sriharikota. Yes. Satish Dhawan Space Center. Satish Dhawan Space Center. SDSC. Sriharikota we have. In that place, we have two launch pad. In a airport, there will be multiple runway, right? Likewise, in that place, we have two launch pad. In India, right now, we have only one launch pad, that is in Sriharikota, Andhra Pradesh. We are currently developing India's second launch pad. If anything comes in news regarding the update of the development of this launch pad, it will be asked. Okay. Second launch pad, it is being developed in Kulasekarapattinam, Tamil Nadu. In Tamil Nadu, Kulasekarapattinam. Tuticorn, Thuthukudi district. The place Kulasekarapattinam, Tuticorn. Second launch pad in Tamil Nadu, in Kulasekarapattinam. PSLV, 36 consecutive successful launches from 1999 to 2017. That's why the name workhorse. Then the payload capacity means how much weight it can carry, excluding its own weight. It can carry 1750 kgs. That is actually, when compared to the normal satellites, it's less only. But small communication, not communication, remote sensing observation satellites will be, small satellites will be having the weight of 100, 200, 300, 500 kgs, which are placed in the lower orbit. So that's fine. 1750 kgs payload capacity, PSLV, Polar Satellite Launch Vehicle. Different variants we have in PSLV. PSLV core alone, no strap-on motor, no extra motor for the boost. Then PSLV DL, two strap-on motors are there. PSLV QL, four strap-on motors are there. DL means dual, two. QL means quattro, four. Right? Then PSLV XL, six powerful strap-on motors for heavier payload. If the payload is more, then PSLV XL variant will be used. This one is PSLV C46. This is core alone with no strap-on motor. Basic. In each and every car, there will be basic model, mid variant, next variant, variants. Right? Likewise, here also we have different variants. Then we have Geosynchronous Satellite Launch Vehicle, GSLV. Geosynchronous Satellite Launch Vehicle, GSLV rocket. Expendable launch vehicle. Expendable means it cannot be used again. Used only once. Expendable means expendable, PEN, only once it can be used. The main agenda of introducing this launch vehicle is to carry heavier communication satellites to geosynchronous orbit. Heavier communication satellites are heavier. For example, The heaviest communication satellite built by ISRO till date. Heaviest communication satellite built by ISRO till date. GSAT 11 that weighs 5854 kgs. 5854 kgs. That much heavy. The satellite which we have built, the heaviest. Actually, we don't have any vehicle which can carry that much weight to that distance. If you don't have that vehicle, then we should take the help of any other space agency's launch vehicle by paying money, right? Generally, these days we are doing these communication satellite launches with the help of France. France's Ariane series of launch vehicle. France, we are taking the help of. See here, Satish Dhawan Space Center, Sriharikota, Satish Dhawan Space Center, GSLV, Geosynchronous Satellite Launch Vehicle, solid fueled first stage, then we have liquid fueled second stage, then very important, indigenously developed cryogenic engine we have. Cryogenic third stage. Cryogenics is a branch of science which deals with Cryogenics is a branch of science which deals with option A, very high temperature, option B, very low temperature, option C, room temperature, option D, all. Cryogenically stored, cryogenically cooled, you might have heard. Cryogenics means extreme low temperature, very low temperature. Cryogenics means this cryogenic engine, we have only one sort of cryogenic engine which we use only in this rocket, only in GSLV rocket, not in any other rockets we use. Cryogenic engine, that too indigenously developed, nobody helped. Our cryogenic rocket, here we use liquid oxygen in minus 183 degrees Celsius temperature. Liquid formed oxygen at a temperature of minus 183. Then liquid formed hydrogen at a temperature of minus 253 degrees Celsius. Minus 253 degrees Celsius. Okay. It is more efficient compared to solid liquid fuels. It will give more thrust. Okay. The cryogenic engine. To the low Earth orbit, it can carry 5,000 kilometers, 5,000 kgs. To the geotransfer or geosynchronous orbit, it can carry 2,500 kgs. You can carry two heavy bags to the first floor. To the fourth floor, you can carry only one bag, right? Similarly, to the nearby orbit, low Earth orbit, it can carry 5,000 kg. To the higher orbit, it can carry 2,500 kg. Half, that's it. To the geosynchronous orbit at a distance of 35,786 kilometers, it can carry only 2,500 kgs. The main purpose of developing this launch vehicle is to carry heavier communication satellites to the geosynchronous orbit, right? How many stages of engine it is having? Three stages. First stage, solid fuel. Second stage, liquid fuel. Third stage, cryogenic engine. 2 years back, a GSLV rocket, GSLV F11, failed. Failed how means the first stage ignited properly, second stage ignited properly, third stage the engine technology was good, but ignition didn't take place. That's why it failed. Recent failure of ISRO. After the failure of Chandrayaan 2. Then we have geosynchronous satellite launch vehicle Mach 3. This can also be called simply as LVM3. Launch vehicle Mach 3. LVM3. This is unofficially called as our Bahubali. Why? Because it can carry more payload. That's it. Designed to launch satellites into geostationary orbit, 35,786 kilometer. We are planning to send human to space with the help of this launch vehicle, Indian Human Spaceflight Program. The name of the program is human we are sending, right, to space. Chandrayana means we have sent lander, rover to the surface of the moon. This is Gaganayan. Not yet done. We are planning to do Gaganayana program. Okay. Payload capacity higher than each and every launch vehicle we have right now. First stage. First stage, two massive S200 solid strap-on booster engines. Second stage, L110 liquid core stage Vikas engine, liquid engine. Third stage, C25 high thrust cryogenic upper stage, cryogenic engine. This is also having in the third stage. Cryogenic, in the cryogenic engine, the fuel will be in the cryogenic engine. Cryogenic is nothing but it deals with very low temperature, right? The fuel here is hydrogen. See, basically, for combustion to happen, what are all the things required? For combustion to happen, what are the things which are required? Petrol, diesel, wood, paper, any combustion. What are all the things which are required? One fuel is required. Then I have a bottle of petrol. Then to start combustion, what else I need? That means ignition temperature is required, right? Ignition temperature is required. Then oxygen, very, very important thing. Without oxygen, combustion will not sustain, right? Oxygen is required. That's why in the cryogenic engine, minus 183 degrees Celsius oxygen, minus 253 degrees Celsius hydrogen is used, right? Hydrogen is the fuel. Oxygen helps in combustion to happen. GSLV payload capacity C. To the low Earth orbit, it can carry 8,000 kg. Nearby orbit. To the higher orbit, it can carry 4,000 kgs. But the heaviest satellite built by ISRO till date weighs 5,854 kgs. That too, that should be placed into geosynchronous or geostationary orbit, 35,786 kilometer. We don't have any launch vehicle which can carry that much payload. We don't have any. GSLV Mark 3. See, GSLV Mark 3 D1. D1 is the name of this rocket. Once this is launched, new one will be built again, because this is also expendable. We cannot reuse. We don't have any reusable launch vehicle till date. Small satellite launch vehicle, recently developed SSLV, small satellite launch vehicle. What ISRO thought, till the time we develop our reusable launch vehicle, let's mass produce more number of small satellite launch vehicle which can carry only 500 kgs, See, if you start a new university, let's say there are a number of universities in Bangalore itself, right? So many universities. If that university develop a satellite, and if that university place that satellite successfully to the space, that university will get good name, right? That university will be ready to pay ISRO to launch their satellite. Likewise, there are so many companies which launch private satellites regularly, on a regular basis. They need the launch vehicle. If I want to go to Delhi, if I want to go to Hyderabad, let's say, Delhi is too far. I will look into the possible options, right? Shall I go by bike? Very risky. Shall I go by car? Difficult to drive alone. Shall I go by bus? Okay, good option. Train, flight. So many options are there, right? What we will choose? Economical efficient. Likewise, each and every person will choose economical efficient options. That is the launch vehicles of our ISRO. Earlier we had PSLV. PSLV payload capacity 1750 kgs, right? The problem is if we have 10 customers who have 50 kg each satellites, 10 means 500 kgs. We need to wait for another 500 plus 250, 750 kgs to come, right? Or plus 250, 1250 kgs to come, right? That's why we have planned, let's develop a small rockets which can carry only 500 kgs so that we can create or make more number of launches in a frequent basis. Turnaround time is very less. That is the reason. Small satellite launch vehicle, payload capacity up to 500 kgs, only 500 kgs. It can be launched into low Earth orbit, then polar orbit, then 300 to 500 kgs to the sun synchronous orbit, up to 500 kg. It can carry. Okay. The main goal is it is low cost, quick turnaround time. Turnaround time means time from launch preparation to liftoff. Easily it can be launched. That's why SSLV was launched, small satellite launch vehicle, SSLV. Three-stage launch vehicle developed by our ISRO for launching small satellites into low Earth orbit. Okay. We can launch single or multiple satellites at a time with the help of this launch vehicle. These specifications are not required. Our PSLV four-staged engine, this one three-staged engine. It can carry up to 500 kg, even 10-20 kgs also it can carry. That much efficient it is. That's why we do have this special launch vehicle. And then turnaround time, 60 days in PSLV. Turnaround time means I need to launch a rocket. I already have developed the rocket, but I need to make sure the suitable preparations are made to launch the vehicle from the launch pad, proper alignment, etc. etc. For that to happen, it takes around 60 days. This one, it takes only 72 hours, 60 days, 72 hours. That's why turnaround time is very less in our small satellite launch vehicle. First stage solid powered, second also solid, third also solid fueled engine, small satellite launch vehicle, SSLV.
Solid fuel is cold.
No, not coal. See, there will be various different type of chemicals which are used. Let's say in our Deepavali rocket, many chemicals are used, right? Similarly, solid fuel will give more thrust for the launch to happen. That's why generally the first stage would be solid fuel, generally, for the initial thrust. Coal and all will give heat, but not the initial thrust pull. Indian Space Research Organization. Before that, how many type of rockets do we have right now?
Four types of
Four different right now. First one,
PSLV,
PSLV, capacity 1750 kgs, which can be used to launch satellites to which orbit?
no,
Low Earth orbit, geotransfer orbit, right? Then we have how many stages rocket PSLV is?
four stages. First,
Solid fuel, second and fourth are liquid fuel. PSLV, Polar Satellite Launch Vehicle, also known as, famously known as workhorse of ISRO. Then we have geosynchronous satellite launch vehicle. To the low Earth orbit, it can carry 5,000 kgs. To the synchronous orbit, it can carry 2,500 kgs. GSLV, three-staged. First stage, solid. Second stage, liquid. Third stage, cryogenic. Then we have GSLV Mach 3, which can carry 4,000 kgs to the geosynchronous orbit, 8,000 kgs to the low Earth orbit. Launch vehicle Mach 3. Then we have small satellite launch vehicle, three-staged engine, three-stage solid fuel. SSLV can carry up to 500 kg, maximum up to 500 kgs it can carry. From 10 kg to 500 kg it can carry any payload. Indian Space Research Organization, ISRO. See, if India wants to start the war with any country, who gives the permission? Who is the head of our defense? Head of Indian Defense Forces? President, right? President. Defense Acquisition Council, etc., will be handled by our defense minister, but the head chief will be our president, not the prime minister, president, right? Then we have Indian Space Research Organization, ISRO. See, every year ISRO will have a budget. This much amount we need for the future programs which we are planning. That much amount will be paid or allotted in the budget. ISRO will also earn money by doing private space launches. Private launches it will do, right? There also it will earn money. ISRO is having its own marketing arm, like in space it have, then Antarix Corporation it has. We'll discuss. The chairman of Indian Space Research Organization, chairman, during the time of Chandrayaan-2, Dr. K. Sivan was there. Later, S. Somanath was there. Right now, the present chief of ISRO. By the time of examination, he might be changed. Okay. Present chief of ISRO, Shri V. Narayanan. Present chief. ISRO chief will be the secretary for Department of Space, which works under the Government of India. Department of Space. Who is the chairman of Department of Space? Who heads the Department of Space means, see, Indian Space Research Organization chief is V. Narayanan, right? For the Department of Space, he will be the secretary. Who? V. Narayanan. Then who will be the chairman for Department of Space? Our Prime Minister. Very important thing to know. Department of Defense will be chaired by Defense Minister. Department of Defense. Likewise, Department of Space chaired by Prime Minister. That is the reason Sri Narendra Modi came to Bangalore during the launch of Chandrayaan-2, because he is the chairman of Department of Space. Our Prime Minister will be the chairman. Important thing. Please note. ISRO was formed in 1969 on August 15th. Earlier it was named as INCOSPAR. Government undertaken. Kind of, yes. Public sector undertaking company. Russia was not divided during the time of our independence. United Soviet Russia, USSR was there. In 1957, USSR launched its first satellite, world's first satellite, 1957. World's first artificial satellite named Sputnik. World's first artificial satellite. Later, Jawaharlal Nehru, during that time, thought, okay, they're doing some development growth in the field of space science. Let us also start in that direction. So, under the leadership of Dr. Vikrama Sarabhai, in 1962, our then Prime Minister Jawaharlal Nehru established our first space agency named INCOSPAR, Indian National Committee for Space Research, INCOSPAR, Indian National Committee for Space Research in 1962. Later, it got renamed into ISRO in 1969. It was developed under the vision of Department of Atomic Energy, founded by Dr. Homi Jahangir Baba. See, under the leadership of Dr. Vikrama Sarabhai, we have started our first space agency, right? Named INCOSPAR. We have started our space agency. Then what we need to do right now? We need to have a rocket. We need to have satellite. We need to have a launch pad. Launch pad we should have. That's why he started India's first launch pad in Tumba, Kerala's Tumba, a place near Tiruvananthapuram, the capital city. Tumba Equatorial Range Launching Station near Tiruvananthapuram, Kerala, in the southern tip of India. In the southern tip of India, India's first launch pad. Right now, it is not used to launch the normal rockets which we have right now. That's why the functional launch pad which we have right now is only Sriharikota. Second one which is being developed is in Kulashekarapattinam, Tamil Nadu. The second launch pad being developed right now. See, very important thing. We are in the northern hemisphere, right? We are in the northern hemisphere. Equator lies below us, near the Madagascar, Africa, southern part of Africa. We have equator, right? Why Tumba Equatorial Range Launching Station? Tells why Tumba Equatorial Range Launching Station? Why the place Tumba? Why it got considered means? Why in Tumba? Why not in Bangalore? Why in Tumba? Why not in Odisha? Why in Tumba? Why not in Gujarat? Right? There should be a reason, right? Close to the sea. Yes, that's one thing. And one more thing, very important thing. See,
Land is the more attached to gravity, more land oceans. So you can launch cable.
then we can launch it from Delhi, right?
In the other oceans, it has less gravity.
No, actually, that is not the case. That is not the case. Gravity will not vary that drastically from land to ocean. That will not happen. Here, what will happen? In the gravitational class, gravity. Newton discovered gravity, we have discussed, right? Then gravitational force F is equals to gravitational constant G into m1 m2 divided by r square. Product of the masses directly proportional to the gravitational force. Square of the distance inversely proportional to the gravitational force. We have discussed, right? Then we have discussed this is the north pole of Earth. This is the south pole of Earth, right? North pole, south pole. The magnetic North Pole and South Pole in the magnetism class. The magnetic North Pole and South Pole, they are little inclined to the geographical North and South Pole. How much degrees they are inclined with? 23.5 degrees, the inclination of Earth, the Earth's inclination, right? This is 11-degree inclination. 11-degree inclination. Geographical North Pole, magnetic North Pole. Geographical South Pole, magnetic South Pole. That's why the geomagnetic equator, which lies 11 degrees apart, it passes through this place. See, where France is located? France,
the European
Europe continent, right? Here in the top. That is not a suitable place for satellite launch. But we do make many satellite launches from the France country's Ariane launch vehicle. But the France is doing all its launches from a place near to the equator, French Guiana. French Guiana is a island in under the control of France. French Guiana is a island which is still under the control of France. From there, it is doing all the launches. France is there in the north. The island is there near the equator. It is doing all the launches here. Likewise, we are doing all the launches from the southern tip. Right now, we have Sriharikota here. Then we are doing next launch vehicle Kulasekarapattinam. Why these places? Because this geomagnetic equator passes from this place. What happens if the geomagnetic equator passes from that place? Earth moves from which direction to which direction? West to east, right? If Earth is moving from west to east, I am launching the rocket from that direction only towards the east. It will give extra push, right? Physically, which we cannot see, but 100% it will give that extra push. Like for that reason, the launch pads are placed in the southern tip, that too near the ocean. One reason near the ocean, because if there is any case of failure, it falls into the ocean, one thing. And other important reason, these places are there in the line of geomagnetic equator. That is the reason. It gives extra push. Extra thrust is attained. That is the reason. That's why earlier it was in Tumba. Now it is in Sriharikota. Next it will be developed in Kulasekarapattinam, Tamil Nadu. ISRO facilities which we have right now. No need to remember all. Just have a look once. Where in other places of India we have different laboratories, different organizations which comes under works under ISRO. Vikrama Sarabhai Space Center, it's in Thiruvananthapuram. Liquid Propulsion System Center, Thiruvananthapuram. The Engine Technology Developing Center. Satish Dhawan Space Center, the launch vehicle, that's in Sriharikota. Then Space Application Center, Ahmedabad, Gujarat. National Remote Sensing Center, Hyderabad. ISRO Propulsion Complex, Mahendragiri, Tamil Nadu. ISRO Satellite Center, Bangalore. ISRO Inertial Systems Unit, they developed the robot, half humanoid robot, Vyomamitra. ISRO Inertial Systems, they developed it. Then Development and Educational Communication Unit, Ahmedabad. Master Control Facility, very, very important. There is a reason why ISRO's Master Control Facility is in Hassan, because from that place, it is very much easier to communicate with the satellites which are launched by ISRO. Do you know? It's there in Hassan. Have you heard? Recently, at 1-2 year back, one of the scientists' son, he got arrested in a ganja or some drug case. At that time, it was very much in news. Such a big scientist, his son involved in this kind of things. Earlier, it was there in Hassan only, in all over the India. Right now, it is there in two places, one in Hassan, one in Bhopal, Madhya Pradesh. Master control facility, it's there in two places, Hassan in Karnataka, Bhopal in Madhya Pradesh. What it will do, once the satellite is launched from the rocket, the satellite will be placed into the orbit. That should be controlled, right? That should be monitored, right? That is done with the help of this station. After the launch, the satellites are monitored with the help of ground station called Master Control Facility that we have in our Hassan and Bhopal, Madhya Pradesh. Very important. Then ISRO Telemetry Tracking and Command Network, Bangalore. Laboratory for Electro-Optics System, Bangalore. Indian Institute of Remote Sensing, Dehradun. Antariksh Corporation. It will become obsolete in few years, but right now it is functional. Antariksh Corporation, it is the marketing arm of ISRO. Marketing arm means, hello friends, we are launching a new rocket next month. If you have any idea to launch your satellite with us, please come. Let's make a deal. That deal will be done by Antariksh Corporation. But right now, the role of Antariksh Corporation is scattered to other agencies like InSpace, NSIL, etc. We'll discuss. But still, Antariksh is working functional. The headquarters is in Bangalore. Marketing arm of ISRO. Marketing arm means a private company wants to launch their satellite. It will make the business deal, how much money it should give to launch their satellite with our rocket. Okay, Antariksh Corporation. Actually, it was in news recently, bad news. Before the time of Corona, they have made an agreement with a private America-based company telling that for so and so crores, we will launch your satellite by this time. But what happened during that time? Many obstacles came. Then COVID came. We couldn't launch the satellite in the prescribed time duration. So they have sued Antariksh Corporation in the court of America for huge, though 200, 500 crores amount. They have sued. That's why it was in news, not now. Few years back, 2, 3 years back.
Sir, in case of private agencies, combined with the start launching the satellites, they should work on that they should work. They should also go into telecommunicated global and NASA.
That is the case. Actually, simply see, listen. I want to start my new travel agency, let's say. I should use the public road. I should use the public parking place. I should use the public bus stand, private bus stand, right? Likewise, ISRO recently started two agencies under ISRO. One is New Space India Limited, and other is InSpace. Those agencies, mainly InSpace, its main function is to help private agencies to utilize the facilities ISRO have. Because if I start my own space agency in Bangalore, we have many private space agencies, private space companies. Even we are planning, we in the sense Indians are planning, ISRO is planning to help private agencies to come into the play. Because NASA helped SpaceX. Now SpaceX valued more than NASA, right? Likewise, India also want one of our Indians, our entrepreneurs to contribute, develop in the field of space. But for that to happen, they need to have huge amount of facility, infrastructure, etc. Right? That cannot be done in a single day. Many number of laboratories, etc. For that, ISRO will help. If I need a laboratory, ISRO will help, but it will take money. That is the case. For that, we have a new agency we'll discuss. NSL and InSpace. Physical Research Laboratory, Ahmedabad. National Atmospheric Research Laboratory, Gadanki, Andhra Pradesh. Northeast Space Applications, Meghalaya. Semiconductor Laboratory, Mohali. Indian Institute of Space Science and Technology, IIST. See, Indian Institute of Science is in Bangalore. IISC. That is different. This is different. This is Indian Institute of Space Science and Technology. This can also be called as India's Space University. It is there in Thiruvananthapuram, Kerala. Thiruvananthapuram, Kerala, it is there in India Space University, Indian Institute of Space Science and Technology. The milestones of ISRO. See, from the time of 1962, we have started with many things, right? Different launches, different development in the launch vehicles, etc. All those are not that important. See, for example, in our life, our 10th max milestone important. At least we do remember. Do you remember your 8th standard English max? No. You might remember your SLC, at least total max, at least a grade, right? Because that is the milestone. +2 milestone, engineering final sem or year, etc. milestone. Likewise, we do have many milestones in our launches, like Chandrayana 1, Mangalayana, then we have Chandrayana 2, which failed, then Chandrayana 3, then Aditya L1 mission. Like this, there are so many missions we'll discuss. Those milestones should be remembered. Okay. Majorly, the many questions will arise from current affairs only, but we should have this knowledge, the milestone, about the milestones. In 1975, we have built our first satellite named Aryabhata. We didn't had any launch vehicle. That's why we took help from Soviet Union, Russia. Intercosmos 1 rocket, Intercosmos 1. Before that, a special technology named sounding rocket. Sounding rocket. See, before you explore the neighboring countries and other countries, you should explore our neighborhood, right? Our country, our state, right? Before you travel to Bali, etc., you should go to at least our Western Ghats, we should see, right? Likewise, before exploring the outer space, before sending satellite to the outer space, we should explore our atmosphere, different layers of the atmosphere. Now we know if we move above the surface of the earth higher into the atmosphere, atmospheric pressure will increase or decrease. If you move up, if you climb to the top of Mount Everest, atmospheric pressure will increase or decrease. The concentration of air around you will increase or decrease. Air decreases, that we know. Pressure is nothing but that is created by the air, right? Air itself, right? See, just imagine. Around the earth we have atmosphere. Indian women won their first ODI World Cup. Indian women recently final against South Africa. South Africa final. Okay. Semi-final Australia. Okay. See, each and every player, they are celebrating by falling on one another. At the bottom we have Jamima. On the top we have Deepti Sharma. Who will be feeling more pressure? Jamima at the bottom, because above her more number of players are there. Likewise, here or here, A, B, where pressure will be more? Above us, so much amount of air is there, right? That will be applying pressure on us. Highest amount of air pressure will be near the surface of Earth. maximum pressure. If you move above the earth, atmospheric pressure will decrease. It will decrease. That's why when you go scuba diving, scuba diving ಗೊತ್ತಲ್ವಾ? Diving deep into the ocean by wearing that special oxygen mask, cylinder, etc. Scuba diving. If you go very deep into the earth, many people died by water applying so much pressure on your ear. Ears might bleed. Your brain might be filled with water. That thing might happen because when you go below, in the water above you will be more, right? It will act more pressure on you. For example, recently I forgot the name. 3-4 billionaires went to see the Titanic ship debris with their private sea vessel. It bursted in the ocean because of the pressure which water creates on that. Simply imagine if we dive into the ocean and if we go deep into the ocean 1 2 3 kilometers, our bones will break because of the pressure exerted by water. That much pressure will be there. Just imagine. If you have time, watch the movie Ghazi Attack. Pranada Gubati, Telugu movie. Ghazi Attack. By the second hand submarine gifted by America, Pakistan tried to attack India with an unofficial war it was, Ghazi attack, right? And we successfully destroyed the Ghazi submarine with our very small refurbished submarine that we have done. In that movie, to avoid the attack from enemy submarine, our submarine dived deep into the ocean. The surface of the submarine dented. If in case it goes deep, it will burst. That much, each and every submarine will be having a range till this much depth it can operate. If it goes below, it will burst. That much pressure will be exerted. Okay. Here also, if you go deep, pressure will be more. If you go above, pressure will be less, right? Sounding rocket means sounding rocket to study the atmosphere, to study the different layers of our earth: troposphere, stratosphere, mesosphere, thermosphere. This rocket was used. What this rocket will do? It will be launched from the surface of the earth. It will go to some distance. From this distance, it will fall by opening parachute. While going up, coming down, it will calculate, it will make many studies. What is the temperature? What is the pressure? What are the components of air, etc. That data will be collected and research is made. This kind of rocket is called as sounding rocket. To study different layers of our atmosphere, it is used. Sounding rocket. It is not used to launch satellites to the space. It is used to study the layers of our atmosphere. It just goes up, falls down by opening parachute. That's it. Sounding rocket. Earlier, we didn't had even this sounding rocket. What we have done, we have purchased sounding rocket from America. Nike Apache series sounding rocket we purchased in 1963. No need to remember. Just listen. Later, we have developed our very own sounding rocket. In your dream, you thought tomorrow you'll make a drone. Will you go and remove the motors of your mixie and start to do the drone tomorrow? Is that possible? First, you should know how drone works, what are the mechanism, what is the minimum drag lift required, etc. You should be knowing, right? For the same reason, India purchased one sounding rocket from America. Later, we have developed our first sounding rocket. India's first sounding rocket in 1967, named RH-75, also called as toy rocket because the weight was only 32 kgs. Only 32 kg weight rocket, small rocket. It was used to study the layers of our atmosphere. India's first sounding rocket, RH-75, launched in 1967. RH-75, sounding rocket only to study the layers of our atmosphere. See, sounding rocket will be launched from the surface. It will go high into the atmosphere and it will fall off by opening the parachute. By the time it might have recorded so much data that will be used. Earlier, what happened? The parachute failed to open many a times. The data was lost due to the crash. Later, they have developed the ground station, telemetry data station that will collect that data in real time, live data collection that happened later. This is our sounding rocket. 1967 RH-75, just 32 kg it was. Then we had our launch station in Tumba Equatorial Range launching station. Why? What was the reason for we to have the launch pad in Tumba itself? Because geomagnetic equator of Earth passes over Tumba. That is the main reason. Geomagnetic equator, not the geographical equator. Geographical equator is down below our India, right? Geomagnetic equator. That is the reason. That is the main reason which we should know. Then, in one central government examination, what they have made, they have asked a question: which among the following satellites are the earlier satellites developed by ISRO? Which among the following satellites are the earlier satellites developed by ISRO? They have given the names of few satellites. Among those, we need to choose which are the early days satellites. The earlier days satellites developed by ISRO. One is Aryabhatta 1975, Intercosmos 1 rocket, Russia's Intercosmos 1 rocket. Then Bhaskara 1, same from Russia, Bhaskara 1 experimental satellite. Then very prepared by India. Each and every satellite which we are discussing right now is developed by India, but we didn't had any launch vehicle till that time, right? That's why it was launched by USSR. Then we have Apple. Ariane passenger payload experiment. Ariane passenger payload experiment from Ariane series of rocket, France, from French Guiana, Kourou, French Guiana. French Guiana is not in France itself. It's there deep in the south near the equator. Here see, in 1979, we tried to launch Rohini satellite from our launch vehicle SLV-3, but it failed. It failed. India's first launch vehicle is SLV-3, launched Rohini satellite in 1980 successfully. Our very own satellite named Rohini, our very own launch vehicle named SLV-3. India's first satellite launch vehicle was named as SLV-3. That is nothing but Satellite Launch Vehicle 3, SLV-3. India's first launch vehicle, SLV-3. No need to remember. First communication satellite, 1984. You need to have such a understanding about the chronology, the timeline, and the important events happened in that year related to all the subjects is that, for example, in somebody's life in 2010, he cleared a SSLC examination. In 2010, his grandpa died. In 2010, they built a new home. Milestone achievements, right? Likewise, in 1984, Indira Gandhi assassination happened. 1984. Likewise, we need to interconnect important years. In 1984, here, 1984, April 2nd, Rakesh Sharma went into space. First Indian, first Indian. He's not an Indian origin person. He's the Indian citizen only. Rakesh Sharma. He is still alive. He lives in Tamil Nadu, I think. But he is living some secluded kind of life without any social media or media attention. Rakesh Sharma. He went into space with a Russian space shuttle named Soyuz T-11. A Russian space shuttle, Soyuz T-11. See, generally, each and every space agency will choose fighter jet pilots for their space mission. Not an ordinary person like we. They will not choose us. They will choose fighter jet pilot. Reason? They will be having the experience of traveling at that higher speed, and their body will be used to it, right? That extreme stress, extreme temperature, extreme speed. That's why. Even Shubhanshu Shukla, fighter jet pilot. Rakesh Sharma was the fighter jet pilot. Then updated version of SLV3, we got ASLV, Augmented Satellite Launch Vehicle, but we are not using it right now. ASLV, Augmented Satellite Launch Vehicle. In 2000, in the decade 2000, GSLV came into the use, Geosynchronous Satellite Launch Vehicle, and PSLV in the 1990s. In the 1990s, PSLV came. Very important milestone missions by our PSLV rocket. PSLV C11, PSLV C25, sorry, 37, 25. PSLV C25, PSLV C11. C means? Huh? C means PSLV C11. Different type of variants were there, right? Different type of variants in PSLV. Best model, next model, higher model, top end model. Likewise, PSLV C means core alone. No strap-on motors are there. No strap-on motors. PSLV C series. Then we have DL, dual strap-on motors. QL, Quattro, 4 strap-on motors. XL, 6 strap-on motors. Okay. Those are the versions, variants of PSLV. Here, PSLV C11, Chandrayana 1 successfully done in 2008. In Chandrayana 1, a satellite revolving around the orbit of Moon was placed into the orbit of Moon successfully. PSLV C25, Mangalayana mission, Mars orbiter mission, launched in 2013, placed into the orbit in 2014. Why 1 year delay? First, it was placed into the geotransfer orbit. By the orbital velocity, it went into that place. Later, it was boosted to the next Mars orbit. That's why it took that much time. Otherwise, generally, the normal launches will happen in few hours only. Mars orbiter mission. Why Mars orbiter mission was why it is the milestone achievement of ISRO means ISRO was the first country in the world which made the Mars, which placed a satellite into the Mars orbit in its first attempt, in its very first attempt. Other countries during the time of Mars orbiter mission, they have already placed orbiter lander onto the surface of Mars, but In our very first attempt, we got successful Mars orbiter mission. Then see, we made world record by sending 104 satellites into the orbit with our PSLV C-37. But right now, this record is broken by SpaceX company by launching 143 satellites in a single attempt to the space. This was the record by us. PSLV C-37. See, simply observe. GSAT. GSAT means Geosynchronous Satellite Launch Vehicle, that is GSLV. GSAT means geosynchronous, to the geosynchronous orbit we are sending the satellite. Geosynchronous satellite. G means geosynchronous orbit. Sat means satellite. We are sending that satellite to that distance. How much distance? 35,786 kilometers. That orbit we will be having which kind of satellites? Communication. Right? This is a communication satellite. Have you heard the name A.S. Kiran Kumar? A.S. Kiran Kumar. He was the chairman of ISRO 3 terms ago. Before the present Narayanan, Somanath was there. Before that, K. Sivan was there. Before him, A.S. Kiran Kumar was there. A.S. Kiran Kumar, he is from Karnataka. Aluru Kiran Kumar, Hassan Alur Kiran Kumar. He got France's highest civilian award. Like we have Bharata Ratna here, right? Like that, France's highest civilian award. Reason, he helped developing space relationship with France by launching many communication satellites by France's launch vehicle Ariane. The reason is simple. If I go buy my car, it will cost 100 rupees. If I travel with your car, that will cost 80 rupees. Good option, right? Likewise, with our launch vehicle, cost and payload capacity was less. How much maximum payload which we can carry?
For the 5,000 in the lower orbit.
That is GSLV. GSLV low Earth orbit 5000 kg and higher orbit 2500 kg. GSLV Mach 3 4000 kg to the higher orbit, 8000 kg to the low Earth orbit. So maximum 4000 kg we can carry to the geosynchronous orbit. That is the reason we have used many a times Ariane series of rocket to carry more weighing satellites. Generally, communication satellites will be very huge and heavy. Communication satellites. Okay. Heaviest satellite built by ISRO till date. Very important. GSAT-11 communication satellite. Next generation communication satellite launched by Kourou, the island of French Guiana. 5,854 kgs. Heaviest satellite built by ISRO, but we don't have any launch vehicle which could carry this much heavy satellite. That's why we have launched this satellite from France's launch vehicle named Ariane. That Ariane is also not a reusable launch vehicle. That is also an expendable launch vehicle. Means each and every time new Ariane rocket is made. See, for example, Ariane 5 VA246, here 247, Ariane 5 VA247. Each and every time new rocket is manufactured. GSAT-11, heaviest satellite built by ISRO. Then Chandrayaan-2 in 2019, it was, let's say, partial failure. If you clear preliminary examination, fail in the mains examination, then also fail in the examination. But for our consideration, somewhat better. Likewise, Chandrayaan-2 program planned in 2019. It contained one orbitar. Orbitar means satellite orbiting in the orbit of moon. Satellite revolving around moon. First one. Then lander. Lander means the module which lands on the surface of moon. Then rover. The lander door will open, rover will come out, and it will move and collect some samples and do the research. Okay. Here what happened? Chandrayaan-2 successfully placed its orbiter into the orbit. I mean satellite into the orbit. That was successful. Prelims successful. Then lander should land properly, right? It failed. If lander failed inside, you are already prepared for interview, but no use, right? Likewise, lander failed to land properly. It crash landed. Rover could not come out. That was the failure. 2019, Vikram lander, Pragyan rover. Vikram lander, Pragyan rover. Then, to overcome this loss, we have made Chandrayaan-3 program again. Chandrayaan-3 program again. There we have successfully placed Vikram lander, Pragyan rover to the surface. New Vikram lander, new Pragyan rover, because that was already crashed, right? That's why name was the same. Vikram named lander, Pragyan named rover. See here. Chandrayaan-1 was made on which rocket? In 2008. PSLV C11. PSLV C11, right? Chandrayaan-1. Polar satellite launch vehicle to place orbitar to the orbit of moon. But here, payload capacity is more, right? We need to carry what? We need to carry lander. We need to carry rover. So it is heavier. So we are using GSLV Mach 3 rocket. Not the normal PSLV or GSLV. We are using our Bahubali. GSLV Mach 3. GSLV Mach 3 M1 rocket we have used for Chandrayaan-2. GSLV F10, the last failure. Here what happened? Cryogenic engine failed to ignite. I told you, no, that last failure of GSLV. Not so important because not in use. Just observe. All the communication satellites are launched by Ariane series of rocket. Ariane. India's first small satellite launch vehicle. Small satellite launch vehicle. In 2022, we have launched Azadi Sat satellite. Azadi Sat satellite on our small satellite launch vehicle. SSLV maximum payload capacity is how much? Maximum 10 to 500 kgs. 500 kgs maximum payload capacity, right? With Earth observation satellite 02, we have launched Azadi Sat satellite. Azadi Sat is a student satellite which students have developed just to study research how to make communication with the satellite from the ground station. That's it, for basic observation. Azadi Sat. Launch vehicle Mach 3 M2 placed 36 satellites into different orbit. This is a commercial mission. All 36 satellites are OneWeb companies. OneWeb, Airtel's OneWeb companies, all 36 satellite. It was a commercial space mission with our new Space India Limited NSAL agency. Like the Antariksh Corporation, we have NSAL. It will help for this private space missions. See, a reusable launch vehicle, autonomous landing experiment. It was successfully tested recently in Chitradurga. Do you know in Chitradurga we have a science space kind of city? Have you heard? There we have aeronautical test range, aeronautical test range near Chitradurga. Here, ISRO successfully tested its reusable launch vehicle, autonomous landing mission. This is majorly done to test the landing gear of our Gaganayana mission, not the reusable launch vehicle. Landing mission of our Gaganayana mission. See, if we send human to space, we should take them back, right? That gear that tested recently, it was successful. Recently, what happened? Sunita Williams was sent to space, right? Sunita Williams. She went to space for a few days. Later, what happened? The returning gear, it failed. She waited there for many months. Later, SpaceX company with their mission took her back recently, few months back, right? Likewise, they have tested this reusable launch vehicle experiment recently. Then see so many commercial operations through NSIL. We'll discuss what NSIL is. Next generation navigation satellites NES-01. Earlier, navigation satellites were named Indian Regional Navigation Satellite System IRNSS earlier. Right now, the name has been changed to Navic. Navigation with Indian constellation, right? This is the second generation navigation satellites of the Navic series. Earlier, we had 7 satellites in the IRNSS series. Later, we have Navic series of satellites to that range itself. Chandrayana 3, very important mission. Launch vehicle Mach 3 M4. The first Chandrayana 2 was made on launch vehicle Mach 3 M1, LVM 3 M1, right? Here Chandrayana 3 is made on launch vehicle Mach 3 M4. Okay. Chandrayana 3 mission successfully done in 2023. Vikram lander, Pragyan rover landed to the south pole of the moon, landed on the surface of south pole of the moon. Is south pole the permanently darker side of the moon? Is south pole the permanently darker side of the moon? Yes, we are discussed, right? To the south pole of the moon on any day, at any point of time in its lifespan, light will not fall. We also see the same face of the moon every day, every time. We also cannot see the other face of the moon. But other face of the moon is illuminated, but we cannot see. But south pole of the moon, it is permanently darker side. We cannot see, and it is permanently darker side. That permanently darker side of the moon is explored, which is explored by our Chandrayana 3 mission. India is the first country. India is the first country to land on the south pole of the moon. On the south pole of the moon, first country, first nation. After landing on the south pole of the moon, our Vikram Pragyan lander, they have given a message called, "I reached my destination and you too." Important quote. You need to note. I reached my destination and you too. And you too means we Indians have landed on the surface of the moon. That means.
In that case, it's only
Hmm?
moon will rotate like this on like
See what is happening. Earth is also rotating, right? Likewise, moon is also rotating. Moon is also rotating. So what happens? As the Earth rotates, moon also rotates. As the Earth rotates, moon also rotates. That's why this is the face of the Earth, let's say, which we are on. This is the face of the moon. This is rotating like this. So we can see always only one face of the moon. Okay. And other face of the moon is also illuminated. This face also illuminated by, but the bottom south pole, it is not illuminated at any point. It is permanently darker side. Do you know how solar eclipse, lunar eclipse are made? How solar eclipse happens? Solar eclipse mean ಸೂರ್ಯಗ್ರಹಣ. ಹಂಗಂದ್ರ imagine, is it possible for the sun to come in earth and moon? Not at all possible. See, sun, star, light source, earth, observer. We are the observer, right? If moon comes in between, what? Moon comes in between, moon. Then what happens? The shadow of the moon falls on the surface of the earth. This is called as solar eclipse. Moon covers the sun. See, you have a big light source here, say there, for example, the diameter of that light, it might be 5-6 inches, that light, see there, right? That can be covered just with the help of this finger, right? Because this finger is near to us, that can cover even the bigger object which is present far from us. Likewise, this moon will completely shadow cover the sun, so that we can see the solar eclipse and the ring when it starts to move away from that position. But the thing is, we can observe solar eclipse in a small area region only. Solar eclipse, if it is happening today, it cannot be seen in many parts of the earth. The reason? Moon is a small object. It can only create a shadow on particular area, not each and every place of the earth, right? That's why this time solar eclipse, it can be seen in South India. In North India, it's rarely visible, or in India it's visible, in Europe it is not, etc. It's there, right? The reason is this thing. Moon is small in size. Then lunar eclipse, how it happens? Very good. Between the light source, sun, and the observer, earth, and the moon, sunlight falls on the earth, shadow of earth falls on the moon, shadow of earth. We, half of the complete this part of the earth can see the lunar eclipse, right? Because the size of the earth is more when compared to size of the moon. Lunar eclipse means the shadow of sun, earth is casting on the moon, shadow of earth. When we can see the lunar eclipse? During day or night? Obviously night. That's why this darker part of the earth means night time we can see the lunar eclipse. The shadow of earth is falling on moon. If the shadow of moon falls on earth, that is solar eclipse. If the shadow of earth falls on moon, that is lunar eclipse. That's it.
That is called Amvasa. You cannot see the moon.
That is different. This is different. ಗ್ರಹಣ ಬೇರೆ, ಹುಣ್ಣಿಮೆ ಅಮಾವಾಸ್ಯೆ ಬೇರೆ. Yes, during the time of full moon and new moon, what happens? The shadow of the earth falls on the moon. That's why full moon, then some part of this is covered, then some part likewise. It happens, right? This is there, but that is not exactly called as the eclipse, because during the time of eclipse you can see that outer ring and the moment of that shadow of earth or the moon and red, bright red moon you can see, right? That is different. Okay, take a break for 5 minutes. We'll continue. Very important mission among the recent missions by ISRO. See, current for UPSC examination, how many months, years current affair which you need to prepare for? 1, 2, 3, 4, 5, 6, 7, 10, 11, 12. How much? From the last year examination to the next year examination, you should be ready with at least 1 year's current affair. 1 year. Okay.
So in the next part,
See, in the mains examination point of view, current affair related static question will be asked. Like for example, if there is anything in news regarding a nanobot, there are few nano robots in the developmental phase which can enter your blood vessel and clear the blocks in your heart. Just imagine. Nano robots, small robots. And there are many nano robots which can target deliver medicine to the particular region of your body's cell. See, right now, what we will do, if we have stomach pain, leg pain, headache, etc., we take the medicine to our stomach, right? It converts to our blood vessel, then it travels to each and every part of our body. If we directly give the medicine to that cell, that will be helpful, right? Targeted drug delivery. Nanorobot. If anything in news regarding nanorobot, they might ask in the sense of related to the new technology. Please shed some light about the development of nanotechnology in India and its importance to the society, economy, etc. They might ask like that. 100% mains examination questions will be linked to the current affair, not directly from the current affairs.
till the June 2023.
Yes, yes.
After the current affairs related questions, the mains will not.
That means, sorry,
So the mains will not after the in case after the
till the time of your personality test, you should go through the current affairs. If any important news during the time of interview, they will ask to check whether you are really preparing for the examination or you're just trying to clear the phases of examination, right? See, it should become a habit. Reading newspaper, reading current affairs. That should not end once you clear the examination. That should continue, right? You should be aware with the current events which are happening around you. You will be the bureaucrat. You should be knowing what is happening around you in the state, in the nation, in the world. That's what they expect. You should know what is happening around you. That's it. At least from last prelims till your selection, you should go through the current affairs. Fine, see here. Aditya L1 mission. Aditya means sun. L1 means there is a point called Lagrangian point. Lagrangian point. Aditya L1 mission on PSLV C-57 rocket. See what our PSLV can do. Polar Satellite Launch Vehicle C-57, PSLV C-57, Aditya L1 mission. The very first mission by our ISRO to study the sun. First Indian mission to study the sun, the surface of the sun, the flares coming out from the sun, the layers of the sun, etc. The first mission, Aditya L1 mission. Here, the spacecraft or the satellite is placed in a hollow orbit called L1, Lagrangian point L1 we'll discuss. It is placed at a distance 1.5 kilometer from the earth. What is the distance between average distance between sun and earth? One astronomical unit. Yesterday we discussed That is approximately 150 million kilometers, one astronomical unit. The distance between our Earth and the Sun, average distance is 150 million kilometer. Now we have launched this satellite to a distance of how much? 1.5 million kilometer. That is not any less. 1.5 million kilometer. That is nothing but 15 lakh kilometer. 1 million mean 10 lakh. 1.5 million, 15 lakh kilometers from Earth to the Lagrangian point L1. Why? To continuously view the sun without any eclipse. How eclipse is formed? By moon coming in between. If we go that far, moon will not come in between. We have crossed the moon. That's why we can see 24 bar 7 the sun. 24 bar 7 we can observe the sun. It carried seven payloads to observe the photosphere. Photo means light, the sphere which emits light. Okay. Then chromosphere. Chromo means color. Color. Chromatics is the branch of science which deals with color. Chromatics is the branch of science which deals with color. Chromosphere. And outer layers of the sun like corona, etc. By using electromagnetic radiation, different particles emitting from it, etc. Lagrangian point L1 will discuss. In 2023, they have successfully made this mission Aditya L1. In 2023 November, very next month after the launch, Helios, the payload which that satellite carried. Payload means, see, I have launched a satellite to the surface of moon. That satellite consists of a thermometer. Satellite consists of a barometer. Thermometer to measure temperature. Barometer to measure pressure, etc. Likewise, there are so many different experimental apparatus, devices to measure different things. Like this, there are 7 different payloads, 7 different experimental operators to detect various things, to research various things. First one, Helios, captures high energy X-ray glimpse from the solar flares. Solar flare means, see, the volcano will be splashing out some lava from the volcano, right? The calm volcano, that will also be splashing out some lava, right? Likewise, flares will be coming out from the sun. That can be observed with the help of this high energy X-ray device called Helios. Then we have solar wind ion spectrometer, Swiss solar wind ion spectrometer. It made an experiment called Aditya Solar Wind Particle Experiment. Means the particle forces charges coming out from the sun. It is measuring. Then we have PAPA, Plasma Analyzer Package for Aditya. In UPSC examination, what they will do, in September 2023, they will give the date. India launched its first solar mission to the Lagrangian point L1 named Aditya L1. Generally, earlier what we used to do, we will study this much only. This is the current affair. But these days what they will do, they will give that part as the question and they will ask Helios related to what? Is it the part of the payload? Papa, is it the part of the payload? Swiss, is it the part of the payload? You need to choose among them. Which among these are the parts of the payload? 1, 2, 3 are correct. 1 and 3 are correct. 2 and 4 are correct. Like this. Okay. Helios, Swiss, Later this one, Papa. Papa means plasma analyzer package for Aditya. The plasma. Do you know about plasma? Not the plasma TV. This plasma. How many states of matter are there right now? States of matter, solid, liquid, a gas like this. Hmm? 3, 4, 5 states of matter. Actually, generally, we do consider 3 states of matter: solid, liquid, gas. Then we have fourth state of matter called plasma. Plasma, extremely high temperature particle. That state, extremely high temperature, plasma state, generally seen in the sun. Then we have fifth state of matter called Bose-Einstein condensate. What? Bose-Einstein condensate. Fifth state of matter, extreme low temperature, extreme high plasma, extreme low Bose-Einstein condensate. Okay, fifth state of matter. We do have how many states of matter right now? 5. Normal 3, solid, liquid, gas. Then we have fourth, plasma. Fifth, Bose-Einstein condensate. Right? Then we have suit solar ultraviolet imaging telescope to detect ultraviolet radiation coming out from the sun. Okay. Aditya L1 mission successfully working in the L1 Lagrangian point. Lagrangian points are called as permanent parking spots. Sicily, he, sun, let's say, he is having more mass, he is having more gravitational pull. Okay. In this place, we have Earth compared to the sun, smaller, less mass, less gravitational pull. At some point, these points are called as Lagrangian points. Lagrangian point 1, 2, 3, 4, 5, 6, 7, 9, 10, like this. Now to the Lagrangian point L1, we have placed the satellite, that spacecraft, Aditya L1 mission. Okay, this is having 7 payloads, right? This point is special because gravitational pull from Earth is also acting on it. Gravitational pull from Sun is also acting on it. Both the gravitational pull of Earth and Sun. That's why it is not revolving around the Earth also, Sun also. It is permanently parked in that spot. That spot is called as Lagrangian point. Permanently parked. Gravitational forces from two bodies. It is maintained in an equilibrium. The attraction force and the repulsion force both are same here. That's why this point called as parking spots, the object will remain in that position only without any fuel consumption or with very minimal fuel consumption. Parking spot, Lagrangian point, very important. If they ask any question about Aditya L1 vision, 100% they will give a statement regarding Lagrangian point. That much important. Lagrangian point is called as parking spots, right? Then we have Gaganayana TV. TV is nothing but a test vehicle. Crew escape system. Reusable launch vehicle. Recently, they have tested, right, how it gets lands back on the surface of the Earth. Similar experiment only. Gaganayana is a program which ISRO is doing to send human to space, right? Gaganayana TV test vehicle D1. This is nothing but they have successfully tested landing gear. They have successfully tested the landing gear. That's it. Under mission Gaganayana. Then C-58, not so important. Proba mission, last year December. No need to worry. To study the sun's corona launched by our rocket, but the satellite is not ours. The satellite is European Space Agency's satellite. Second generation navigation satellite, Navig series satellite. Then very important SpaceX mission. Space docking experiment. Important space docking experiment successfully tested in 2024 December. What do you mean by docking? Docking. In the port, in our ports, ships come and dock. Ships, they will come and dock there. Dock means with the help of that, what do we call that? With the help of this, it will be docked or placed stagnantly in that position, right? Space docking experiment means they have successfully tested two satellites being connected to each other in the space. Two satellites, two moving objects being connected to each other. I am moving in my bike at 60 km per hour. My friend comes with his bike 60 km per hour. If both of our speeds are same, we can handshake. We can pass something. We can communicate, right? Likewise, the space docking experiment here, they have demonstrated in the orbit docking capability between two satellites, connection between two satellites. How it will help means, for what it will help means, in the future we are planning to have our own space agency, space station, right? India is planning to have its own space station. In few years to come, by 2030 probably, International Space Station will be dismantled. International Space Station, it's already too old. It will be dismantled in few years. Later, India will be having its own space station called Bharatiya Antariksha Station. Bharatiya Antariksha Station. For this mission, this is a crucial technology, SpaceX mission. Very important thing to know. SpaceX means Space Docking Experiment. Successfully done in 2024. Crucial basic technology for Bharatiya Antariksha Station. Very important mission happened this year. Very important mission. Very first time, with the collaboration of ISRO and NASA. ISRO and NASA. NASA ISRO Synthetic Aperture Radar. NISAR means NASA ISRO Synthetic Aperture Radar. We have launched this satellite with our rocket GSLV F-16. GSLV F-16. This is the first of its kind. Very first time we both have collaborated in this field, Earth observation mission. Dual frequency L-band, S-band radar system with high resolution imaging of Earth surface, ice, etc. Earth observation satellites are used to detect the changes in the weather, ecology, etc. And also the main reason is defense. For the very first time, India, with the collaboration of NASA, launched this Earth observation satellite named NISAR. NASA ISRO Synthetic Aperture Radar. To which orbit? Low Earth orbit or higher orbit? Observation satellite will obviously in low Earth orbit. That's it. To the low Earth orbit, right? Radar full form. Radio detection and ranging. Radio detection and ranging, where radio waves are used. Here, two frequency band, L band, S band radio waves are used here. Right. In the last year, I mean this year, 2025, the only important mission which we need to know is NISAR. In 2024, SpaceX mission, then technology, then Gaganayana test vehicle, that landing gear testing, those things are important. Aditya L1 very, very important, even though it was launched in the last year. Aditya L1 very, very important, right? Here, see, ISRO started two new companies, two new agencies under it. Under ISRO only they will function. Two new agencies. One is InSpace, full form Indian National Space Promotion Authorization Center. Space Promotion Authorization Center. Indian National Space Promotion and Authorization Center. InSpace. InSpace. This is an autonomous. Autonomous means they can work on their own, right? Nodal agency approved by Union Government of India, will be governed by Department of Space. Department of Space chaired by, yes, chaired by Prime Minister. Secretary will be whom? Secretary will be the Chief of ISRO. Chief of ISRO, Chairman of ISRO will be the Secretary of Department of Space. This organization, the InSpace, will act as a medium between ISRO and private space sector. In India, not other country space agencies, Indian private space agencies. If we all think to start our very own satellite developing agency, Nittur Space Agency, then that new private agency will be helped by InSpace. InSpace will give all the necessary help. InSpace, not exactly funding. It will help with the resources technology present. Private agencies will be allowed to perform space activities. They will give the permission to launch the vehicle, to maintain the satellite, etc., and use the facilities of ISRO, equipments and facilities of the ISRO. They will give the permission for launching, etc. They cannot build their own launch station, right? Launch pad. In India, we do have only one launch pad. Then a private new company, it can not build their own launch pad. That's why each and every help will be given by InSpace. In space, in between that gap, this agency will work. In between whom? The facilities of ISRO, which ISRO is having, and the private agency. It will help the private space agencies of India, only India, not private space agencies of other countries of India. They will help with the facilities. InSpace. Then we have NSIL, Public Sector Enterprise, Central Public Sector Enterprise, New Space India Limited. New Space India Limited. Government of India established New Space India Limited, Public Sector Undertaking Enterprise, under the Department of Defense, Department of Space, under the Department of Space, to commercially exploit research and development work of ISRO. What is the difference between commercially exploiting the research and development facility and helping the private agencies? There is a small minute difference. See, for example, this institution have this administrational, and the setup, right? A camera, a digital board, seating, etc. If this institution helps other people living in this area, okay, fine, you are also from our area, you can come and use this facility. We will help you. That is different. Okay, I have this place. Let me see how much money I can make out of this. With anyone coming in, anyone from outside this area also. Likewise, in space, what it will do, its main agenda is to help private space companies of India to grow in space. Okay, helping private space agencies to grow. The idea or goal of NSIL is to commercially exploit, to make money out of the facilities which we have right now. For example, I am launching PSLV tomorrow. You will launch your satellite with my rocket. You will be paying me money. That will be handled by NSIL. A private, for example, recently the European Space Agency launched its European Space Agency launched its satellite called Proba 3. Proba 3 with our rocket, right? Our rocket PSLV C-59. That will be handled by whom? NSIL, New Space India Limited. Okay, New Space India Limited. Like this. In space full form, Indian National Space Space Promotion and Authorization Center, NSIL, New Space India Limited. Main goal, commercially exploiting the facilities present with ISRO, making money out of the facilities which we have. That's it. That is the goal of NSIL. Next, we'll see the future technologies of ISRO. We have two future technologies with which ISRO is working with. One is scramjet engine technology. Scramjet. ISRO is developing a technology named scramjet, means supersonic combustible ramjet. Supersonic combustible ramjet. Supersonic speed means what? More than the speed of what? More than the speed of sound. More than the speed of sound. Just imagine if an object moves more than the speed, in the more than speed of the sound, that the speed is called as supersonic speed. For example, the fighter jet. Few missiles move in the speed of supersonic speed. For example, our BrahMos missile. Have you heard the name BrahMos missile? It is a supersonic cruise missile. It travels in a speed more than the speed of sound. Then our fighter jet Rafale, our fighter jet Sukhoi moves more than the speed of sound, Mach 2, Mach 2.8 speed, right? Like this. Here, what they are planning, say, for the combustion to happen, what are all the things required? One, fuel is required, then oxygen is required, then ignition temperature is required, right? Fuel, oxygen, ignition temperature. For ignition to happen in your bike, you have spark plug, spark ignition engine, petrol engine, right? Here they are planning. Generally, in the supersonic engines, they will be storing oxygen in the cylinder, just like they store fuel in the cylinder. Because at that higher speed, at that speed, it will be difficult to take in oxygen from the atmosphere. It is moving at very high speed, right? It is difficult to take in the oxygen. They are developing a special technology where this scramjet engine is also called as supersonic or breathable engines, breathing engines. Breathing engines. That means at a supersonic speed, air intake mechanism they are developing to take in air from the surrounding atmosphere. Right now, the supersonic vehicles carry oxygen. If you carry oxygen also, the load will increase, the efficiency will decrease, right? That's why they are planning to develop this engine, special engine. Supersonic combusting ramjet, still in the experimental phase. In 16 successfully conducted a test, but many tests are remaining. Scramjet engine. Then we have the future technology RLVTD, reusable launch vehicle technology demonstrator. Technology demonstrator is nothing but a demo piece, demo model. A reusable launch vehicle, that means same rocket can be used multiple times. This rocket will go, place the satellite, come back, then that can be used again, right? That is reusable launch vehicle. Do we have any reusable launch vehicle right now? Among 4 launch vehicles which we have right now, is there any launch vehicle which can be reused? No, we don't have any, right? The technology they are demonstrating right now. After the class, just search on YouTube and SpaceX reusable launch vehicle landing. Just see how it will happen. That rocket which is coming back from the space, launching, you have seen, right? The combustion starts, the attachment will open, it will go. Here, ulta, it will come back, it will stand vertically it will come and come near to this mechanism, it will hold it back. Very beautiful thing. First time when SpaceX tested, it failed, it blasted into pieces. Later, they were successful. That mechanism only we are developing, reusable launch vehicle. This reusable launch vehicle which we are developing is half the shape of an aeroplane, half the shape of a rocket. Top winged aeroplane kind of thing, bottom rocket kind of thing they are developing. Reusable launch vehicle technology demonstrator. Right now, no update regarding this. If there is anything in news, then it should be taken care of. Reusable launch vehicle. Okay, let's see the important launches made by other space agencies of the world. That too, each and every launch is not that important. Well, remember few important milestone achievements. First one, world's first artificial satellite launched by whom? USSR in 1957, named Sputnik 1. World's first artificial satellite. In 1957 October, they have launched, right? Later in the month of November, they have sent a dog to space. See how much hurry they were in. They sent a dog to the space. The first animal which went to space is this dog named Laika the dog. It died. Unfortunately, this dog died because it couldn't withstand that extreme pressure, temperature, etc. It died. Later, they took some time. They took some time and they have made their next experiment named Sputnik 5, where they have sent, see, 40 small mice, 2 big rat, 1 rabbit, some fruit flies, a plant, and a pair of dogs called Belka and Strelka. Along with these 2 dogs, so many other animals and organisms they have sent. These dogs returned safely in 1960. By the time of 1960, did we have our space agency. Not even INCOSPAR. INCOSPAR started in 62, right? They have sent two dogs. They came back successfully. Then later, Laika died. Belka Stelka came back safe. During the time, USSR made many lunar missions. See, till date, till date, only country which sent human on the surface of moon is America. No other country sent human on the surface of the moon. Many countries sent human to the space, not on the moon. Nearly 12 people till date, 12 people walked on the surface of moon. All are from America. All from America. Here, Luna series of experiments by Russia, where they have sent rover on the surface of moon. During that time, you might have heard about the World War, right? Russia on the one side, US on the other side. Here also, some kind of Cold War. Russia, if it does some experiment, US will be in hurry to do other achievement. Luna Code 1 rover made by Russia. Then NASA, world's first weather satellite, no need to remember. Then very important thing, Vostok 1 mission. For the very first time in the history of humankind, in the history of humankind, a man, human, was sent to the space named Yuri Gagarin. Yuri Gagarin. He went to the outer space and came back. That's it. Yuri Gagarin. 1961. First human who went to the space. Later in 1963, first woman went to the space. Valentina Tereshkova. Valentina Tereshkova went to the space and came back safely. Both Yuri Gagarin and Valentina Tereshkova. Yuri Gagarin, Valentina Tereshkova. Then, in 1969, July 20, before the launch of our Indian Space Research Organization, ISRO launched on August 15th, right? In July 20, Apollo 11 mission, Apollo 11 mission, America, NASA sent three humans to the moon. Three. The first one to land on the moon is Neil Armstrong, the main commander. The second one to land was Edwin Buzz Aldrin. Edwin Buzz Aldrin. The third person stayed inside that capsule itself. He didn't come out on the surface of the moon. He was handling the controls of the space shuttle. His name is Michael Collins. He died 2 years ago. Michael Collins. First person to land on the surface of the moon, Neil Armstrong. See, there are so many theories. Have you heard any this controversial theories regarding the moon landing? Have you seen? There are so many theories telling that this is a fake news. They haven't landed on the moon till date. They have made fake claims. But according to our books, etc., we have considered. That's why, in the point of examination, we need to consider yes, they have landed on the surface of the moon. That's it. Then, first person to do the spacewalk. Spacewalk means what? In the space, they cannot walk, they can just float, right? There will be no gravity, microgravity. The first person to do spacewalk, the USSR, Russian, Alexei Leonov, first spacewalk. See, main thing others are objecting is how the flag it is like this when there is no gravity. Why the shadow is falling on this way, etc. Theories. Let's leave it. Then first Indian who went to space, Rakesh Sharma, 1984. 1984, April 2nd, on Soyuz T-11, Russian space shuttle. Then Kalpana Chawla went to space. Kalpana Chawla, first time she went to the International Space Station in 1997. Later in 2003, while coming back, she died. 2003. Kalpana Chawla. Indian origin, American citizen. Sunita Lynn Williams, she is a US Navy officer, American Navy officer, Indian origin. In 2006-7, first space flight she made, and nearly 14-15 days she stayed in the International Space Station. Later, in 2012, second International Space Station mission she went for 32 to 33 days. Later, in the Boeing Starliner 2024, she commanded the spacecraft. Leader, commander. Later, what happened? When she went to the space the last time, let's go there. She is the only woman who spent more than 500 days in the International Space Station. More than 500 days. Then completed 7 spacewalks, 550 hours plus. More amount of time she stayed outside the International Space Station. And very important thing, in 2017, she ran marathon, virtual marathon, by staying in the International Space Station only on the treadmill. See, for example, if the marathon is for 7 kilometers, the time duration will be there, right? She ran on a treadmill in the International Space Station. Virtual marathon, she ran. Sunita Lynn Williams, along with Butch Wilmore, went to International Space Station in Boeing's Starliner space shuttle. She was the commander. She was the leader. Okay. They went in June 2024 for 8 days. They planned for only 8 days, 8-day mission. What happened due to some technical failure? Due to the thruster failure, the helium leak happened. They couldn't come back in the same space shuttle. International Space Station, a big capsule, a space shuttle, it goes and attaches to that. That is the space docking. Later, they will go inside and do all the research work, and they will come back to the Earth. This space shuttle, the spacecraft failed. Later, she waited there for over 9 months. Just imagine. She went there for how many days? 8 days. Then waited for 286 days. Many people lost hope that whether she comes back alive or not. What happens if a person stays longer time in the space? Her bone density due to the microgravity will reduce, her health will deteriorate. That is the case. Then later she
The
space station, inside the space.
but how come she walked 50 days outside?
50 days means not continuous 50 days. She, if there is any maintenance, etc., research work that needs to be done, a rope or a harness that will be attached to the International Space Station, she will come out. She will do the operation. Then she will go inside.
The outside of the
Outside of the station, not very far away, just by attaching the harness. Later she will go in. That duration will be counted. The total duration is 50 plus hours from these many years. In March 2025, this year, they came back successfully with the help of SpaceX Dragon spacecraft. SpaceX, they took her back safely. Then Sirisha Bandla, she went to the outer space with a private space agency, Richard Branson's Virgin Galactic flight. Not in news. Actually, Richard Branson, rich fellow, Unity 2022 mission. The agenda of this program is they are planning to have their private space tourism company. Space tourism company. This is the first experimental flight which they have made. What does space tourism means? You pay them 10, 20, 50 lakhs. They will take you to the outer space. They will show you, see, Earth looks like this, and they will take you back. That's it. This is for sure. By the time of our retirement, see, in the last generation, people used to go to other states for trip, other places for trip. This generation going to other countries easily. Next generation will go to space for trip. Have you imagined that we will use mobile phone one day, video call one day, right? That happened, no? Like this, like that, space tourism will come to life one day. Within 10 to 20 years, 100%, space tourism will boom. Recently, in October 2025, this year news, ancient life's evidence was observed by Perseverance rover. Perseverance rover by NASA. There is a crater. See, the surface of Mars is also not a perfect sphere. It is having undulations, right? In the Jezero crater, the famous crater, Mars Jezero crater, organic carbon and minerals associated with the microbial metabolism was detected from the finding of the Perseverance rover. Organic carbon means carbon present in our carbohydrate, carbon present in our any mineral, nutrient, etc. That kind of carbon. They haven't detected any organism. They have detected carbon, organic carbon. That's it. That could have been developed by the microbial metabolism. That's it. Perseverance rover. Human space flight exploration program. Before sending human to space, we are planning Gaganayana mission, right? Gaganayana program we are planning. Under this, our Shubhanshu Shukla in June 2025, India's first astronaut went to International Space Station. Earlier in 1984, our Rakesh Sharma went to space, right? He just went to the outer space and came back. He didn't went to the International Space Station. First Indian citizen who went to International Space Station is Shubhanshu Shukla. He went recently along with the other three, total four astronauts. Axiom 4 mission, and conducted many biological experiment on algae. Tardigrade. Every year or so, tardigrade will come to news. This is very important. Tardigrade. Very weird microscopic organism named tardigrade, which can withstand extreme pressure and temperature. Tardigrade. See how weird it looks. Tardigrade. Tardigrade. Microscopic organism. It can live in the space without oxygen, without atmosphere, at extreme high temperature, pressure, etc. tardigrade, right? He studied about this organism tardigrade. Right now, it was not seen on any planet, but it is present in the earth. They got to know it can live in the space. That's why they are experimenting at what temperature, pressure, gravity it can withstand, etc. Right? Tardigrade, very important organism to know. Axiom 4 mission launched in June 25, 2025, returned on July 2025. SpaceX Crew Dragon spacecraft, private space agency, SpaceX. Axiom Space was the operator along with SpaceX. Commander was from America, Peggy Whitson. Indian, Shubhanshu Shukla. Poland, Slavoj Uznansky. Then Tibor Kapu from Hungary. For the first time, we have made a space mission with these two countries for the very first time. That is one important thing to know. 18 days, they stayed in the International Space Station. Shubhanshu Shukla. Objective, research and development, that's it. 60 plus experiments were conducted from 31 plus countries. Joint space mission between India, Poland, Hungary, and USA, America. Shubhanshu Shukla, Whitson, Shubhanshu Shukla, Kapu, and Nansky. 4. That's why the name Axiom 4 mission. Very important mission which we need to know. World's important space agencies. National Aeronautics and Space Administration, NASA, Americas. Russian Federation Space Agency, or it is also called as Roscosmos. Roscosmos. Roscosmos in their Russian language, RFSA in English. ISRO, Indian Space Research Organization. CNSA, China National Space Administration. JAXA, Japan Aerospace Exploration Agency, Israel Space Agency, then the National Center for Space Studies, CNES, France's Space Agency. Even Pakistan has their own space agency, Superco. Pakistan. Okay. Tomorrow we'll discuss about different type of energy resources. Once we complete with that, we'll move on to defense technology, right? Tomorrow, not tomorrow, on Monday. Thank you. No, actually, International Space Station is with the collaboration of many countries.